Unit 4, Lesson 3, this is all about some right triangle trig and using trig properties. So super quick review, right triangle trig of some stuff you probably already know from geometry, or you should know. So this right here is called theta. So this is what we're going to kind of refer to as our reference angle. So this is theta, and this is what we're going to look at. Okay, reference angle. So from our reference angle, we have three different sides. We have the side that's opposite, which means across. You have adjacent, which means next to. And then you have your hypotenuse, which is the longest side, and it's always across from 90. So notice that we have 90 degrees over here. Your hypotenuse is always across. So we can form 6 different ratios. So we have sine, cosine, tangent, cosecant, secant, and cotangent. And again, sine and cosine, secant, those are related to each other. We have a nice kind of cool way to remember this, and it is called SOHCAHTOA. Okay, SOHCAHTOA. So this is like saying for our sine function, we are going to go opposite divided by hypotenuse, which again, you can see that's right here. Sine, opposite divided by hypotenuse. Whereas cosine is it stands for adjacent over hypotenuse. Again, these are the ratios. And then tangent, you can see, is opposite over adjacent. So how do we remember this? We remember this by using SOHCAHTOA, okay? SOHCAHTOA means opposite over a hypotenuse. Ka means adjacent over hypotenuse. And then toa means opposite over adjacent. Now, maybe what's new, or maybe what you didn't quite remember, is that, again, these are reciprocals of each other. So all you have to do is flip-flop your numerator and denominator. So cosecant is hypotenuse divided by opposite. Secant is a hypotenuse divided by adjacent, and cotangent is adjacent divided by opposite. So that was, again, just a super quick recap. You might have a triangle that looks something like this. Okay, say that this is theta right here. We've got a right angle, we've got 3, we've got 4. And you may need to find, it might say, tell me what sine of theta is, tell me what cosine of theta is, tell me what tangent of theta is, and you might have to do all 6 of them. So again, SOHCAHTOA, sine is opposite over hypotenuse. This is my reference angle. So opposite over hypotenuse. I don't know what the hypotenuse is yet, but I can use something called the Pythagorean theorem. Okay, Pythagorean theorem, which is a squared plus b squared equals c squared. And c squared is always your hypotenuse, which, again, we know that this is my hypotenuse because it's across from 90. So 3 squared plus 4 squared equals c squared. 9 plus 16, 25 equals c squared. Therefore, c equals 5. So for sine, it's opposite over hypotenuse. That's going to give me 4/5. Cosine is adjacent over hypotenuse, which is going to give me 3/5. And tangent is opposite over adjacent, which would give me 4/3. Okay, going to move on. But again, you could also flip those and find cosine, cosecant, cotangent. We've got 2 cases of special triangles. So again, these are good to kind of devote to your memory. It's not the best. Okay, again, this works with right triangles. The first one is going to be a 45, 45, 90 triangle. So again, 45, 45, 90, talking about the interior sides. And so again, what's useful is that this angle and this angle are the same, and that goes for the same thing for the sides. So again, if this is x and this is x, then whatever we have for my hypotenuse is x times the square root of 2. So whatever my sides are, I multiply it by the square root of 2, and that's going to give me my hypotenuse. The other triangle, the special triangle, and again, you'll see these quite a bit, they're good to see, is a 30, 60, 90 triangle. So I like to think about it as you have a short leg, you have a long leg, and then you have your hypotenuse, okay? So my short leg, we'll say, is across from the 30. So that's going to be red. Let's see here, 30, 60, 90. Got to move that. And so we're going to call this the short leg, which we're going to say is X. And then across from my, not the short leg, but we're going to call it the long leg. We're going to say that the long leg is across from there. That's going to be over here. And to get this, we need to go X multiplied by the square root of 3. So if we call the short leg X, this long leg is going to be X times the square root of 3. And then our hypotenuse, which again is across from the 90. Oh, I keep doing that. Across from the 90 is our hypotenuse. That's going to be double our short leg. So 2 times the short leg, which would also just be 2x if we stick with our x. So we've got x times the square root of 3, and 2x. All right. Let us keep going. So again, you can use this to like fill in stuff. I know that you guys have done these before, so we're going to keep moving. Just wanted to remind you of some of these special angles. Again, just kind of the big ones, the 30s, the 60s, the 45s. So you can use that because these ones will come up more frequently. So again, if you start recognizing numbers and say, hey, I remember that, or I've used that before. Okay, so we also have these things called trig identities, okay? So these are going to be super useful, and again, you got to know them so that you can apply them and substitute them in. So let's take a look here. So the first one that we have kind of pulled up here is just, again, reciprocals. How do you get cosecant? You take sine and you put it underneath 1. You make it in the denominator. Same for, again, secant. What do you have to do? You take it, you put it underneath 1 to get cosine. They're reciprocals. Quotient identities is, again, dividing. So tangent is opposite divided by adjacent, which, again, if in this case, your sine is going to be your y and your cosine is your x. So you have like y divided by x, whereas in cotangent, it's going to be the opposite. You have cosine on top and sine on the bottom. Again, they're reciprocals. And then these last two identities, these are ones that we will definitely use. And again, you can manipulate them by saying, hey, maybe I want to subtract. Maybe I want to subtract sine squared. So I could say something like cosine squared equals 1 minus sine squared or something. You can take what is written here, subtract 1 on something on both sides, and you can get another way to manipulate it. Okay. So we'll do a quick quick couple examples, maybe one or two, using trig functions, and then you'll be good. So if we draw this, let me draw this triangle real quick. I'm going to have a right angle. I'm going to have theta. This is 0.8, 1, and 0.6. So to find the value of, let's see here, let theta be an acute angle such that sine of theta equals 0.6. Find the values of cosine theta and tangent theta. So we want to try to find cosine and we want to try to find tangent. So the first thing I'm going to look at is I'm going to say, okay, I know that I can use the Pythagorean identity of sine squared plus cosine squared theta equals 1. And it gave me in the directions that sine of theta equals 0.6. So I'm going to say, all right, I've got sine squared plus cosine squared theta equals 1. I'm going to plug in this sine theta that I was given. So I'm going to say, okay, 0.6 squared plus cosine squared theta equals 1. Subtract that on both sides. So minus 0.6 squared minus 0.6 squared. What is that going to be? 36, which means cosine squared theta equals 0.64. That looks nice because how do you undo a square? You need to take the square root. So if I take the square root on the left, I need to take the square root on the right. And so I get cosine of theta equal to 0.8. And so we can look and say, oh yeah, that's what we were kind of describing, is that in a triangle that looks like this, our sine values are the y's and our cosines are the x's. If we wanted to find tangent, again, we now know that tangent is sine over cosine. Which we could say is 0.6 over 0.8. We just found those, and we get 0.75. Okay, let's do an example with a trig identity. Do two different examples. Part A here, we'll do cosine theta of multiplied by secant theta equals 1. And then B is secant theta plus tangent theta multiplied by secant theta minus tangent theta equals 1. Snuck it in there. So I'm going to use, for this first example, I'm going to say, okay, well, I know that cosine can also be written as 1 over secant. So if I multiply by 1 over secant, which is, again, the same thing as multiplying by 1, this is going to cancel out, and this is going to cancel out. And all I'm left with is cosine theta equals 1. All right, let's keep going. Start by multiplying this. So again, use your distributive property here, 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 and here. So you're going to get secant squared theta minus, you just have to think about these trig identities as variables. Secant theta, tangent theta, plus, again, because we have a subtraction and an addition, so those are going to cancel out. That's nice. And then subtract tangent squared. So again, right here, these are going to cancel out. So you're just left with secant squared theta minus tangent squared theta, which, if we look, I can manipulate this and say secant squared theta minus tangent squared theta equals 1 by subtracting it on both sides. Therefore, this whole thing equals 1.